This is the first question for today. Very good, Rita. No, Durga. E is given by minus del V. Very good, Abhay. See, this way you can calculate the magnitude of electric field and then energy density is half epsilon naught E square, na?
Yes, sir.
This option. Please check, everyone. Clear?
Yes, sir.
So you have to calculate the total charge enclosed in a sphere of radius 1, which is centered at the origin. Very good, Arun. Very good, Abhay. Hint from my side is you can make use of Gauss's law. In order to calculate the charge, you can make use of Gauss's law because electric field is known. And you know that flux is Q by epsilon naught and flux is E dot ds. Yes, Ritika, very good. So Q is equal to epsilon naught E dot ds. This, so only R cap component will be there. So radius is unity, so it is epsilon naught alpha 1 square and integration of sine theta obviously from 0 to pi and phi from 0 to pi. Please check everyone. This is how you can do it. Clear?
Yes, sir.
This one. Yes, Rita, very good. Yes, Abhay. No, Ritika. No, Arun. No, Durga. I want all of you to contribute. Until or unless you try yourself, you are not going to learn the things. See, angle is 30 degree with the vertical. Let us see now. So if I draw a line which is perpendicular to this surface, it will go like this. So then this angle will also be 30 degree because this angle is 30 degree. Angle between two lines is equal to angle between their perpendiculars. Now if this is 30 degree, this is electric field, this is ds vector. Angle between electric field direction and ds vector will be 150, na? Because total is 180. Please check.
Yes, sir.
This is clear. And we know
Yes, sir.
net flux is zero, na? And net flux means flux through curved surface and flux through the plane surface. This one. This is plane surface. This is curved one. Okay. So it means flux through curved surface is equal to negative of the flux through plane surface. And flux through plane surface is given by area into electric field into cos of angle between E and ds. It is E dot ds, na? E ds cos theta.
Yes, sir.
So value of cos 150 is, can I write
Root 3 by 2. Minus
as
root 3.
cos 180 minus 30? So it will be minus cos 30, na? Please check.
Yes, sir.
Okay, let me discuss then. See, if this is theta, if I make a small angle d theta like this, then the length of this arc, it will be r d theta, na? Okay. And if I extend this, then this angle will also be theta. And this is the direction of dE vector. So it will be dE cos theta. And here it will be dE sin theta, na? Because charge is lying only on this much portion. Okay, so any test charge placed here, it will be repelled by the charge on this circular wire, na, segment at O, because we have to find the electric field at point O. So I have resolved this electric field into horizontal and vertical components. Okay, beta? This is
Yes,
theta.
sir.
Yes, sir.
So it means now I need to find dE cos theta and dE sin theta, and then I can club them both to get electric field vector. Okay, so let us see what we can do. So what I can do right now is I can find the electric field due to this small element that I have considered, and then I can integrate it with respect to 0 to pi by 2 to get the electric field due to complete element. Okay. So what is the value of dE?
1 by 4 pi epsilon naught dq by r square. Where
dQ.
r is a radius.
Yes. So what is dQ? What is the charge on that small part?
Lambda
Lambda.
r d.
Lambda r d theta, na? Is it clear? So
Yes, sir.
R and R will get cancelled. So we are left with lambda d theta by r. So electric field cos theta I cap Then we can integrate it from 0 to pi by 2. Minus sine 0 I cap plus cos 0 j cap. This one will also be there. No?
Yes, sir.
So this is clearly A option. Please check.
Yes.
Clear to all?
Yes, sir.
This is the formula. This is 4 pi epsilon naught R. Na? So this is coming out to be 5 into 10 to the minus 10 joule. Please check everyone.
So a spherical shell can be treated as a capacitor also, right?
Definitely anything that can store charge, it is having a capacitance. No?
Okay, sir.
Because the mere purpose of capacitor is to store charge.
Okay, sir. Got it.
Otherwise also, if you remember, you have been using this formula, na? And this is CV.
Yes, sir.
Yes, Ritika, very good. Okay, let us see. So correct option is B. So there are two concentric spheres. One is this other is this. So charge Q is at the center and the outward electric flux through the inner sphere is phi, while that through outer sphere is double. It means there must be a charge of similar kind in the region between two spheres, only then the flux through outer sphere can be double. Na?
Yes, sir.
Otherwise also you can assume it to be Q1. Okay. And what you can do is, through this one it is phi, through this one it is, suppose it is given to be 2 phi. Okay. So let's call this to be phi dash, which is 2 phi. So phi dash is Q plus Q1 by epsilon naught, which is 2 phi, and 2 phi means 2Q by epsilon naught. So Q plus Q1 is 2Q. So Q1, it comes out to be Q only. Okay. Clear? So automatically it comes out to be Q. Done, everyone?
Yes, sir.
Yes, sir. सर QY R1 होना चाहिए ना?
Q by
R1.
Q upon D minus Q upon R.
yes. Option में there is something wrong. एक option में R1 आएगा. ये वाला R1 होगा. This one. Because inner है ना ये.
Yes, sir.
ये R1 होना है. This is the answer. Okay, C. Inner radius R1, outer radius R2 encloses the charge Q inside. This is charge. So due to induction, negative charge will be induced on the inner surface. And positive charge will be induced on the outer surface. This, na?
Yes, sir.
So in order to find the potential at the center, for this it will be Q by 4 pi epsilon naught R2. For this it will be minus Q by 4 pi epsilon naught R1. And for this charge it will be Q by 4 pi epsilon naught D. So clear cut D option is there. So B option is the answer. See how. So electric field is given by lambda by 2 pi epsilon naught R. And R is square root of A square plus B square, because point is AB0. Please check.
Yes, sir.
So electric field vector will be given by E into R cap. And how I can define R cap? It is R vector by R. So it will be like lambda by 2 pi epsilon naught A square plus B square square root, and R vector will be AI plus BJ by A square plus B square square root. So it will be like lambda by 2 pi epsilon naught A square plus B square AI plus BJ. Please check. Instead of I, they are calling it EX cap, EY cap, like that. Clear?
Yes, sir.
Charge density is given and the shape is given. You have to find the total charge on the lamina. Yes, Abhay, very good. Yes, Arun. This is the shape of the lamina. Rita and Durga, it's Durga, you have given two answers. Are not you sure about your answer?
The second one, sir.
No, first one is correct, second is wrong. So this is the shape of the lamina, and we know that total charge is given by sigma ds, and ds is like dx dy. Sigma is 15y, so it will be like dx y dy. So x and y, they are not independent. So y is linked to x. So if we integrate with respect to y first, then the limits will be from 0 to 1 minus x square, and x independently goes from minus 1 to plus 1. Okay. So it will be y square by 2. And y square means 1 minus x square ka square. So it is clearly an even function. So I can write this as twice 0 to 1. 8. Please check. Clear?
Yes, sir.
These all questions are from electrostatics part. Okay. So I'm going topic wise. This is from electrostatics. So very good question. Conceptual understanding is required. Okay, I'm marking it star, important one, because you need to know the formula. No, Durga. You have to find the electric field at this point. Yes, Abhay, Durga, it's correct. So you have to find the electric field at this point. Let's call this point as P. Okay. So this sphere, it has been cut. So for this kind of question, I told you earlier also that you can consider this full sphere, and then along with this, you can consider this sphere, but along with the negative charge. Okay. So now this point, it is outside this sphere and inside this bigger sphere. So both the formulae are required. Okay. Electric field inside the solid sphere and outside the solid sphere. Clear?
Yes,
Yes,
sir.
sir.
And electric field inside a charge carrying solid sphere is rho r by 3 epsilon naught. And at outside point, it is given by 1 by 4 pi epsilon naught q by r square type. Isn't it?
डेंसिटी फॉर्म में तो लिख सकते हैं ना, रो आर बाई 3 एप्सिलॉन नॉट.
हाँ, रो फिर वो लिख सकते हैं रो आर क्यूब बाय 3 एप्सिलॉन नॉट आर स्क्वायर. फिर ऐसे लिखना पड़ेगा.
यस सर.
Okay. So now what you have to do is, for inside case, the radius of the bigger sphere is capital R. That is not required, but small r is r by 2, because the distance of the point from the center of the sphere is r by 2. Okay. So for inside, it is r by 2, this formula. And for outside case, radius of the sphere is r by 2 first of all, and the point is at a distance r from the center of the sphere. Please check everyone. Is this thing clear to you? ये sphere का radius होता है, ये center से distance होता है. So for the small sphere, radius of the small sphere is r by 2, and distance of this point from the center is r, na? This total. Please check. So electric field at point P will be difference of these two. This term will be positive, this will be negative, no?
Yes, sir.
You know now why I'm putting the negative sign, because we have carved out that sphere. So I am considering the full sphere with positive charge and small sphere with negative charge. Okay. So rho r by 6 epsilon naught, rho r by 24. So rho r by 24 epsilon naught common. Rho r by 8 epsilon naught. So if I compare it with the given result, it says rho r by n epsilon naught. So comparing it with rho r by n epsilon naught, we get n equal to 8. Please check. So this was the important thing that you need to remember. And then application is even more important because you need to take care of the radii and the distance also. Okay. Clear to
Yes.
everyone? Okay. This one. Hurry up, be quick so that we can discuss as many questions as possible. Let me make the diagram first for this. So this is the point P where we need to find. Yes, Durga, Rita, Abe. So it will be sigma by 2 epsilon naught j cap minus sigma, in fact. And because it is to the left of this one, so again minus. Because it will be repelled. This will attract, this will repel, this will also repel. So all of them, they are in the negative y direction. Na? Clear?
Yes, sir.
Yes, sir.
So charge density is given. So you have to find the electric field for R less than R. So first of all, you need to find the enclosed charge, na? This will be the charge. Please check everyone.
Yes, sir.
Done.
Yes, sir.
Again, a good question and very easy, very, very easy. So this is the position of equilibrium that they have shown. Hint is try to find the forces, various forces acting on the spherical ball. C. C option is the answer. Let us see how. So this is the diagram that is given. So now if I try to find the various forces, then mg, weight is acting vertically downward. Here is the tension in the string. So this is how we can resolve, and this is the electrostatic force, and it is getting balanced by T sine 45 because it is given that the ball is in equilibrium. Can we substitute for F? F is equal to QE. Q is the charge on the ball. Tangent 45 is 1. And we know that electric field due to sheet of charge sigma by 2 epsilon. So sigma is 2 mg epsilon naught by Q. C option. Please check.
Yes, sir.
Flux of the function. Function is given, you have to find the flux. So area integral, nothing else, and the phase is also given. Direction of the normal vector is also given. And area is along y cap, na? So it will be dx.
dz by dx.
So only y cap component will be relevant for us. So it will be 3xy z squared dx dz, area integral. And at this particular phase, value of x is fixed, na? The value of y is fixed, that is 1. So it will be 3x minus z square, na? And now let us see how x and z they are varying.
0 to 1.
0 to 1, 0 to 1 both, na? So it will be like, but two integrals are there, na? So first let us integrate with respect to x.
सेपरेट कर देंगे तो होगा सर, इंडिपेंडेंट
सर सेपरेट करके कर लेंगे, अलग अलग तो भी हो जाएगा, लिमिट सिमेट्रिक है ना, सेम है।
सेपरेट कैसे करेंगे? तब भी तो डबल इंटीग्रल करना पड़ेगा आपको।
लिमिट और इंडिपेंडेंट है ना सर, डिपेंड नहीं करते एक्स जेड
बेटा तब भी तो ये बनेगा ना, मल्टीप्लाई तो करेंगे ना आप।
यस सर।
यस सर।
इंडिपेंडेंट तो हो ही नहीं पा रहे ना, ये देखिए, व्हेन यू मल्टीप्लाई देम तब भी यहाँ पे तो दो इंटीग्रल करेंगे आप, यहाँ भी तो दो करेंगे। गॉट इट?
यस सर।
इंडिपेंडेंट तब होता अगर ऐसा कुछ होता 3x इंटू जेड स्क्वायर, तब आप बोलते कि x वाले को अलग से कर लो, ये अलग हो गया, ये वाला अलग हो गया, तब होता है इंडिपेंडेंट। ओके, हियर यू कैन नॉट डू देम इंडिपेंडेंटली, दो तो आपको करने पड़ेंगे एज माइनस साइन है। सो 3x स्क्वायर बाई 2 x z square 0 to 1. Now you will integrate with respect to 2 decimal places. How much?
1.12.
1 2? No, I don't think so.
1.67 आ रहा था मेरा.
70 ना, तो 6 1 10
1.16.
1 1 6 1 7 ही हो जाएगा ना राउंड ऑफ करके, तो फिर 1.166 आ रहा है ना, बिकॉज प्लीज चेक. क्लियर?
सर
Yes.
उससे भी सेम ही आ रहा है अलग अलग करके.
बेटा आप समझे ही नहीं मेरी बात. अलग कैसे हुए आपके, बताएंगे आप मेरे को?
सर जैसे 3x dx
हाँ
इंटू
तो
dz दोनों की लिमिट भी दी गई तो अलग अलग करके कर ली.
हाँ सेम ही आएगा, बट वो अलग थोड़ी ना हुआ. चलो आप उसको अलग बोल रहे हो, ठीक है, उस सेंस में. उसमें भी तो 2 इंटीग्रल ही हो रहे हैं ना आपके, एक थोड़ी ना हो रहा है.
ये सर.
वो तो सेम ही आना है, वो तो ऐसे कर लो वैसे कर लो, उसमें कोई फर्क नहीं. IIT Jam 2019. So I have discussed all the questions from electrostatics part. इसका तो well defined formula is there ना,
ये
q
सर.
square by 8 pi epsilon naught. So just substitute the values, nothing else. इसको ऐसे कर लेते हैं, 1 minute. Can I write it like this? So now I can write 9 into 10 to the power 9 na, in place of 1 by 4 pi epsilon naught. So how much you are getting?
सर हमें तो 1/4 पाई एप्सिलॉन नॉट की यूनिट में फाइंड करना ना, तो वैल्यू क्यों रखेंगे?
In units of, okay. फिर तो वैल्यू की नीड ही नहीं है. फिर तो 25/8 you need to find ना.
ये सर.
How much? 3.125. This is the answer. Please check. Clear?
Yes, sir.
ये सर.
Long thin wire. Here is a wire. You need to find the electric displacement vector at point P. Yes, Durga, Rita. See, according to Gauss law, D dot ds integral is equal to Q enclosed, na? And area will be 2 pi RL. If I take this to be equal to R, then there will be a cylinder, na? Okay. So 2 pi RL equal to Q enclosed. So electric displacement vector will be Q enclosed 2 pi RL. So 8 pi. Radius is 20 mm. So it is already charge per unit length, na? So in place of Q enclosed by L, we have substituted this. It is only 2, na?
Yes, sir.
So it is numerical answer type then. So 2020 work done, electrostatic energy. Yes, sir. Yes, what about others? Okay, let me tell you then. This is the answer. Let us make the diagram. So we need to find the electrostatic energy or the potential energy of the configuration. When you are bringing the first charge, then no other charge was present. And when you are bringing the second charge, then first charge was present. So it will be Q square by 4 pi epsilon naught L. And when you are bringing the third charge, then two of them are present. So there will be two terms. Please check. So Suppose initially these charges are not there. So when you are bringing this first charge, then no work is being done. Na? And when this charge was present and you are bringing this one, then electrostatic energy of these two will be this one. And when these two are present and you are bringing this one, then electrostatic energy of this one with this one is this. And this one with this one is this. Okay, please check.
Yes, sir.
This one is fresh one, 2021. Yes, Arun. So who will tell me how to solve it?
We can use del dot E equal to rho by epsilon.
Yes, then
That would give me rho, that is charge per unit volume. Then we can do a volume integration.
yes. See, E dot ds is q by epsilon naught. And we need to find the charge. But if I go for the surface integral, it will be very much time consuming. Na? So I can make use of Gauss law over here.
Yes,
And I
sir,
can
मैंने इसी
replace
से की है.
this E dot ds as del dot E dv. Please check. Can I do this? And now you need to find the divergence of this. What is the divergence of this?
8x plus 3.
It is 8x
Plus 3.
3. And what is the volume element?
Dx dy dz. right?
Yes, because it is cube. And now you can integrate it independently. Limits of all of them, they are going from 0 to 1. Na? So now you can integrate it independently. This is the independent integration case that I see. Clear?
Yes, sir.
So there was K also, na? So I need to write K as well. So this one will be so easy, na? This way. Otherwise, you can see it will take a lot of time if you go for the surface integral. So this is the real application of Gauss divergence theorem. Okay.
Yes, sir.
Yes, sir.
So every time there is one question, at least from electrostatic. Let me check if there is another question in 2021. There is only one question. Let us move to another topic. So this was from electrostatics. Na? Now let us see from capacitor and dielectrics part. Yes, these kind of questions are very important. Yes, Arun, Rita, very good. Yes, Durga. So Z is normal to the interface. So it means XY is the tangential component, and tangential component always remains constant. So A option is wrong. So it may be B, C, D, because in all of them, XY components, they are same. So it is all about tangential component which is going to change. Normal component, sorry. So let us see how normal component it gets modified. Okay. So D normal 1 is D normal 2. Epsilon 1 E normal 1 equal to epsilon 2 E normal 2. So E normal 2 will be epsilon 1 by epsilon 2 E normal 2. This is epsilon R1 by epsilon R2 E normal, sorry, 1. And E normal 1 is 4. Epsilon R1 is 4.
It's 5 by 4 into 4 cap.
Check, let me check. Yes, 5 by 4 into 4. So it is 5, na, normal one. So it will be plus 5 K cap. So D option, please check. Because normal component means along Z axis. Clear? That's
Yes,
how you can find.
Yes, clear.
E tangent 2 is E tangent 1. Tangential component remains constant. Okay. So that's all for today, students. So we will stop here. So we will continue with the electricity and magnetism part even tomorrow. Okay, students. Bye-bye. Take care.
thank you, sir.